Alright guys, so today we are going to talk about hyperbolas. What does it kind of look, the word itself, look like? Like a parabola, right? You see the bola there, like in parabola. So it's basically parabolas. So here, what you see here, notice that I have two cones, okay? And they're connected by their tip there, right? This is actually called a hypercone. Okay? It's called a hypercone. So it kind of makes sense that if I had a hypercone, I would get a hyperbola, right? So it's like parabolas of hypercones. So anytime you have a cone that's connected like this, tip to tip, it's called a hypercone. And notice, just like with the regular cone, I'm cutting it which way? Straight down, vertical, right? I'm coming straight down. And do you see basically what I'm getting here? They're the yellow parts. You see the yellow parts? So basically, what does it look like? It looks like two parabolas, right? And that's exactly what it is. Okay? It's just two parabolas. So it happens basically, you get a parabola going up and a parabola going down, and they're actually together. Okay? You get a parabola going up and a parabola going down. Okay? So there are two types of hyperbolas. There's the one that we just saw, the one that opens up and down. Okay? There's the one that opens up and down, and then there's one that opens left and right. Okay? So these things, they have certain, just like before, they have a specific equation. And I can tell what things are based on that equation. So if you notice here, see these lines? Okay? These lines that are kind of making this X. What do you think those are? These are my graphs. And notice, what are these graphs not doing? They're not touching. So guess what are these? What do we call those lines that graphs don't touch? Starts with it. These are asymptotes. Okay? So these right here are asymptotes. I have two asymptotes. And they just make an X, right? So, and then my hyperbolas follow the asymptotes, either on top and bottom or on the left and right. So this technically right here is my center. It's where the asymptotes meet. That acts as my center. Okay? So my center is where the asymptotes meet. So technically not part of the graph itself. Okay? What are these? Well, think about parabolas. They have vertex, but there's two of them. So these are my vertices. Okay? Because I have two of them. So basically, guys, from equations, from analyzing hyperbolas, I should be able to tell three things. Where are my vertices? Actually, four things. Where are my vertices? Where are my center? Where do my asymptotes look like? And then, does this thing open left to right, or does it open up and down? What's up? Well, they can't be min and maxes, because if you say that this is the minimum, but there's lower points than that. And you can't say this is the maximum because there's higher points than that. So these technically have no mins and maxes, right? Because these go on forever. So they go on forever to the bottom, go on forever to the top. Make sense? Okay? So they're both just vertices. Alright? So for hyperbolas, we have two types. They open either left or right, or they open up or down. Okay? They both have vertices, they have centers, they have asymptotes. So what we're going to do is figure out, well, how can I tell? Just like before, how can I tell all that information from the equation? Okay? So it's just going to take some analyzing. Alright? This is the important stuff. This is what you need to for sure write down. Okay? I'm going to pause. Alright, so this is analyzing a hyperbola. So I give you two equations, and there's a reason I give you two equations, okay? First of all, do y'all notice something about the equations themselves? Okay, but do they look familiar? They look kind of like what? They kind of look like ellipse. What's the difference? It's a very subtle difference. They're subtracting. So the difference between an ellipse and a hyperbola is that it is subtracting. That's the minor difference, okay? So you got to be paying attention. If it's addition, then it's an ellipse. If it's subtraction, then it's a hyperbola. Now, y'all did say that the x's and the y's and all that are switched, right? Now, that doesn't necessarily mean that it's a hyperbola. What it does is it tells you something about the hyperbola, okay? So the fact that it's subtraction, that means it's a hyperbola, okay? The fact that it's switched, that tells you which direction that it opens, okay? So if the x is first, okay, then it opens left and right. If the y is first, then it opens up and down. Has everybody got it? So the center is still the same center, h and k, but remember, that tells me the center of what? Because remember, that tells me the center of the asymptotes, right? So then, from there, I can determine the vertices, and again, there's subtle differences here. Very subtle differences. So, to find the vertices, if it opens left and right, to find the vertices, all I have to do is add, it has to be h plus a and h minus a. The k's don't change. Got it? So if it opens left and right, k's are the same, but the h moves left and right based on whatever my a is. And again, I get my a from here and here, right? And then the slope of the asymptotes is always going to be positive, negative, b over a. Okay, positive, negative, b over a. Now, if it opens up and down, again, the difference is that the y is first. The y is first. But to find my vertices, notice what doesn't change here. The h's don't change, but you make your k's different by adding and subtracting your b. Okay? All right, so keep this handy. Keep this handy. You're going to be going back and forth to it. And then what we'll do is we're going to see if we can basically analyze a hyperbola. All right, so here we go. Here's our first example. Okay? It says analyze and graph the hyperbola. Analyze and graph the hyperbola. So I have parentheses. X minus 3 squared over 25 equals y plus 1 squared over 49. Did I say plus or minus? Minus. Y plus 1 squared over 49 equals to 1. So, first of all, what is this? Well, is it a circle? Is it an ellipse? Is it a parabola? Is it a hyperbola? How do you know? Because it's subtraction. Got it? Because it's division, n equal to 1, but it is subtraction. Please understand that that's the only subtlety, right? So, I know this is a hyperbola. I know this is a hyperbola. Okay? So, as always, let's start analyzing it. Let's start breaking this down. Can you tell me the center? What is the center? 3 and negative 1. Does everybody understand where I'm getting that from? Okay, here's my h, here's my k. Why is this, if it says plus 1, why is my center negative 1? Good, because remember, it's always should be subtraction. But if it's addition, that means you're subtracting a negative. Does everybody go with that? So this is my center. This is my center. Okay? Then you should be able to tell me, does this open up or down? Or left and right? Okay? Does it open left and right or up and down? How can you tell? That's simple. The x is first, so it opens left and right. Does everybody got it? So this opens left and right. Okay? So, I know my center. I know that it opens left and right. Good? Okay. Here's the tricky part. Here's the tricky part. Let's talk about my vertices. Let's talk about my vertices. Okay? How do I find my vertices? Okay, so what do I need first? I need A and B first, okay? So it's not necessarily part of my questions, but I do need to know. What's my A? Where are you getting that from? How do I know this one's A? Because it's with the X. That doesn't change. So my A is 5. What's my B? You with me? Okay. Now, to find my vertices, I have a little work to do. Okay? Because the equation says h plus a comma k and h minus a comma k. Now, so what's not going to change here? What is my k? So then I still know that, right? So the other ones then, my h, so 3 plus 5, comma negative 1, and 3 minus 5, comma negative 1. So then what are my vertices? Does everybody see how I found that? So basically, to find the vertices, you just use that little formula. Okay? So I knew my h was 3. I know my a is 5, so I'm going to add 5 and subtract 5 from my center, basically. You with me? And then it says, what are the slopes? According to your rules, what are the slopes? It says plus or minus b over a. So in our case, it's going to be plus or minus what? Now, what do I mean by plus and minus? Not that it could be. It's both. It's both. Because remember, how many lines do I have? I have 2. And notice, one's positive, the other one is. Does that make sense? Okay? So, same thing. It doesn't matter if it opens up or down, left or right. There's 2 lines. There's 2 asymptotes here. Okay? So, I have 2 slopes. One's positive, the other one's negative. Now, with all this information, I should be able to graph it. Okay? With all this information, I should be able to graph it. So, you either have graph paper or you're making yourself a nice little graph here. Okay. Ready? What do I need first, do you think? I need my center. Okay? So, center is 3, negative 1. So, 1, 2, 3, negative 1, bam, there's my center. Okay? There's my center. Now, from my center, guys, what I'm going to use next are my slopes, because I need to figure out my asymptotes first. That's the most important. I need to figure out that x, okay? So now, what is that slope? What does slope mean? Let's go back to algebra 1. It's just rise over run. So according to this, I'm going to go what? Up 7. Which way across? What does that mean? Always to the right. So I'm going to go up 7 and right 5, and then I'm going to go down 7 and right 5. Okay, so from this, so that's what? 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7 up and 5 to the right. And then what do you think I'm going to do with that? Draw a line, right? Because I know. So try your best to kind of draw that line. And then again, I'm going to do the same thing, but that was positive, so now I'm going to do my negative. And the only thing that changes is instead of going up 7, I'm going to go down 7. So 1, 2, 3, 4, 5, 6, 7 to the right 5. And again, connect them with a straight line, as straight as you can. We good with that? So, what's the first thing I graph when I'm graphing hyperbolas? The asymptotes. How do I graph them? What do I need to start off with? The center. So you need your center first, and then you use your slopes. You with me? Okay. Now what do you think I can draw? My vertices. Okay? Because I know where my vertices are. So my vertices are 8, negative 1, and negative 2, negative 1. So negative 2, negative 1 is where? 2 to the left and 1 down. So right here. Right? And 8, negative 1. So this was what? 3, 4, 5, 6, 7, 8. So right here is my other vertice. And then again, how do I know how this looks like? Well, we already said that it opens which way? Left and right. So I know that it's on that my hyperbolas are on this sides of the x's. Do you see that? Yeah. And basically, guys, there's asymptotes there, so I know that what happens. What do you do with asymptotes? Just kind of hug them. That's all you're going to do. You're just going to kind of hug the lines. So it's going to look something like that, like this. Okay? So the red line, this is the actual function. This is the actual shape of the graphs. The blue lines are just my asymptotes to kind of tell me where to put these. Okay? So, let's recap. I saw the equation. How did I know what it was? Because of the subtraction. It looks like an ellipse to me, right? But the difference is very simple. This one is subtracting. The fact that I know it's subtracting tells me that it's a hyperbola, correct? And then I needed to find my what? My center. How do I find my center? Same way I always have, h and k. So there's my h, there's my k. You with me? Okay? And then I figured out that it opens left and right. How did I do that? Because my x, all I was looking for, which one's first, the x or the y? So in this case, the x was first, so therefore it tells me that it opens left and right. And then I figured out my vertices. How did I figure out my vertices? H. Why did I use this formula and not the other formula? Because it opens left and right. That's why I did that first. Does that make sense? So because it opens left and right, all I'm gonna affect is my h. I'm just gonna add my a and subtract my a. I knew my a based on this square root of 25. Correct? Okay. I found my two vertices, and then from there I found my what? What are these slopes of the what, though? Remember, these are slopes of what? Slopes of the asymptotes. These are slopes of the asymptotes. Okay? So basically my x's. And then when I graphed it, how did I graph it? What's the first thing I did? Was my center, and then what did I do? Use my draw the asymptotes because I use my slopes, and then what did I do? And then what did I do? How? Just hug the asymptotes. Remember, you can't cross them, but you know that it's got to get close to them. Okay? Any questions? Think you can do it? All right? Try it. Try it. Good job. All right, so we determined that it was dividing by 1 because there was nothing written there, and I know I can't divide by 0, so it has to be divided by 1. My center was negative 2, 0, because why does it look different than the way the equation is different? Why does the center look like it's backwards? Because it's going up and down, right? So the y was first, but it doesn't change my h and my k, correct? H is always with the x, k is always with the y. So I know it opens up and down because my y is first, right? What else now? What can you tell me? You got to be able to tell me my vertices. Which equation am I going to be using, or what am I going to be messing with this time? The k, right? So the h is not going to change, so it's going to be k plus b, and h is not going to change, k minus b. So then what do I got to know first? I got to know my a and b. I got to know my a and b. What's my a? 1. Where are you getting that from? Well, the square root of 1 is still 1. And what's my b then? 3. You with me? Okay. So then my vertice is negative 2, comma, my k was 0 plus 3, and negative 2, comma, 0 minus 3. So then what are my vertices? Negative 2, 3, and negative 2, negative 3. Y'all with me on that? And then what's the last thing I need? Slopes of the what? Slopes of the asymptote. Is that okay if I abbreviate? So it's the slopes of the asymptotes. What are the slopes of the asymptotes? Well, I can leave it as 3 over 1 because rise over run, right? So it's okay. You can write it as 3 as long as you know that you're still running 1, right? So it's positive and negative. Why is it both positive and negative? There's two asymptotes. All right, so here we go. Let's see if we can sketch this bad boy. What do I... Let me just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Close enough. All right, so what do I graph first? The center. And according to this, where's my center? So right there. Okay, now what? Good. So I'm going to use the slopes of my asymptotes to draw my asymptotes, right? According to this, what do? So up 3, 1, 2, 3, over 1, bam. And then that's a line. And then down 3, 1, 2, 3, to the right 1, bam. There's my other line. So there's my x. Looks a little tight, right? But it's okay, because I know what this is supposed to look like. What do I draw next? The vertices. According to this, my vertices are -2, +3, so right here, and -2, -3, so right there. So you can tell, based on where my vertices are, that my parabola is going to, or my hyperbola is going to be here on the top and the bottom, right? And again, I already know that because I know it opens what? Up and down. So now, guys, just basically hug the asymptotes. And there you go. Okay. So how many conic sections do we have now? 4. What are they? An ellipse? How do you get an ellipse? No. Like how do you get a cone? From a cone, how do you get an ellipse? You cut it slanted, right? You cut it slant way. What was the math term for slant? Anybody remember? Obliquely. Good. Obliquely. When you cut it obliquely, basically means at a slant, it becomes an ellipse. What else? A circle. How do you get a circle from a cone? You cut straight across, horizontally. You cut it horizontally, right? What else? Parabola. How do you get a parabola from a cone? You cut the vertical, right? Cut straight up and down. And then how do you get a hyperbola from a cone? It's actually not from one cone, it's from a hypercone, right? So, and then how hypercones look how? Where do they connect? At the tip. So be very careful, because let's say I had a cone. Is that a hypercone? No, because they're connected at the what? At the base. I have no idea. 2 cones connected at the base. I don't know. Right? So be very careful. Alright. So then I cut a hypercone which way? Vertically, straight up and down. And then I get a hyperbola. Look, I spelled it wrong. Hyperbola. What's the difference between an ellipse and a hyperbola? Adding and subtracting. Which one's which? Ellipse is adding. Hyperbola is subtracting. And why does it matter sometimes? Does it matter like with the hyperbola? With the x and the y being first? Yes, it does. Because that tells me whether it opens up and down or left and right. Does it matter with an ellipse whether x's and y's? No, why not? First of all, it's addition. So does it matter 2 plus 3 and 3 plus 2? No. But does it matter 3 minus 2 and 2 minus 3? Yes, you get 2 totally different answers. So that's why there's a difference from here. Any questions with your conic sections? All right, fantastic.